Welcome to the review. So this is what we're going to be doing. You will have a test tomorrow. We're going to review what we covered in Chapter 4 today. So we're going to start by reviewing Chapter 4.1 through 4.3. So what we're going to do is make a table and graph a function with a given domain. Then we're going to identify the range of the function. Well, our function is y equals 3 minus 2x. So if we make our table, we're going to have x and y. In the middle, we'll have 3 minus, not negative 3, 3 minus 2x. So it says our domain is x is less than or equal to 0. So we know that it is equal to 0, so we can put a 0 there. Then if it's less than or equal to, we need to have negative numbers. So I'm going to put 3 negative numbers. Negative 1, negative 2, and negative 3. So if I put 0 into our equation, then we get 3 minus 2 times 0. 2 times 0 is 0. 3 minus 0 is 3. 3 minus 2 times negative 1. Negative 2 times negative 1 is positive 2, so 3 plus 2 gives us 5. 3 minus 2 times negative 2. Negative 2 times negative 2 is 4, so 3 plus 4 gives us 7. And then finally, 3 minus 2 times negative 2, or negative 3, sorry. Negative 2 times negative 3 is 6, plus 3 is 9. So our coordinates then are 0, 3, negative 1, 5, negative 2, 7, and negative 3, 9. We're going to make points at those coordinates. So 0, 1, 2, 3 is our first point. Negative 1, 1, 2, 3, 4, 5 is our second point. And negative 2, 1, 2, 3, 4, 5, 6, 7. We can't go any further, so we can't graph our last point, but we can make a line just through these 3 points. Now remember though, our line has to stop here because our x cannot go more than 0. Remember, our x is only less than 0. So if we're looking then at our range, our domain was 0, negative 1, negative 2, negative 3. Our range is going to be our y. So 3, 5, 7, 9. Okay, same thing here. It says make a table, graph the function with the given domain, then identify the range of the function. So we got to make another table. We have x and y. We have negative 2x plus 5. Now our domain is x is greater than negative 2, but less than 6. So what I'm going to do is I'm just going to pick negative 2, 0, 3, and 6. So I just pick 4 numbers in between negative 2 and 6. So if I put negative 2 times negative 2 into our equation, plus 5, negative 2 times negative 2 is 4, plus 5 gives us 9. Negative 2 times 0 plus 5 gives us 5. Negative 2 times 3 plus 5. Negative 2 times 3 is negative 6, plus 5 is negative 1. And negative 2 times 6 plus 5. Negative 2 times 6 is negative 12, plus 5 is negative 7. So if we graph this, we can't graph 2 or negative 2, 9, because that goes off the grid. We can graph 0, 5, though. 0, 1, 2, 3, 4, 5. We can graph 3, negative 1. 1, 2, 3, negative 1. And we can graph 6, negative 7. 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6, 7. Now our line is going to be a line segment this time. So we need to just create a line from this point and then all the way up. Now negative 2, 9 is probably going to be somewhere around here. So our line segment's going to end right there. Go from there down to there. So it can only go to negative 2 and 6. Our range is 9, 5, negative 1, and negative 7. Now you could have picked any numbers in between negative 2 and 6 that you wanted to. I just picked negative 2, 0, 3, and 6 just because. Alright, here it says find the x-intercept and y-intercept, then graph the equation. Well, how are we going to do that? We know that for the x-intercept, our point is going to be at something x 0. And we know that our y-intercept is going to be 0 something y. So what we got to do is we know that this is our x and this is our y, just like this is our x and this is our y. We know that our y here is 0. So what we're going to do is we're going to put this 0 in for y. So we have 6 times 0 plus 3x equals 18. 6 times 0 is 0. We don't need that anymore. We just get 3x equals 18. Divide by 3. And x equals 6. So we know our new ordered pair is 6, 0. So our x-intercept is at 6, 0. Our y-intercept is just the opposite. We know that x is 0 this time, so we're going to put 0 in for x. So we have 6y plus 3 times 0 equals 18. We don't need this anymore. 3 times 0 is 0. We just divide by 6 then. We get y equals 3. So our y-intercept then is going to be 0, 3. If we graph these 2 points, we have 6, 0, so that's our x-intercept. And 0, 3 That's our y-intercept. And we can graph these by connecting our dots. And there's our line. Alright, so this one says you are planting an ornamental garden that has a total area of 200 square feet. There are two sizes of ornamental plants you have chosen for your garden. Each small plant requires 4 square feet of space, and each large plant requires 8 square feet of space. This situation can be modeled by the equation 4x plus 8y equals 200, where x is the number of small plants and y is the number of large plants to be placed in the garden. Find the intercepts of the graph of the equation, then graph it. What do the intercepts mean in this situation? Well, we first need to find our x-intercept then. So we know we have something x and 0. So it says that x is the number of small plants. So I'm putting in 0 for our y, and we're looking for x. So 4x plus 8 times 0 equals 200. Now 8 times 0 is nothing, so we don't need that anymore. So we get 4x equals 200. Divide by 4. Divide by 4. We get x equals 200 divided by 4, which comes out to be 50. So x equals 50. So our x-intercept is at 50, 0. Now if we do the same thing over here for our y-intercept, we have 0 and then something y. So this time we're putting in 0 for x. So 4 times 0 plus 8y equals 200. Now 4 times 0 is 0, so we don't need that anymore. We get 8y equals 200. Divide by 8. Y equals 25. So our y-intercept is at 0, 25. Now, it says that our x was the number of small plants. So on our x-axis, I'm going to put small. On our y-axis was our number of large plants. So I'm going to put large on our y-axis. So I'm going to go up by 5s, I think. So actually, I'm going to go each of them by 10. So 10, 20, 30, 40, 50, 60. Okay, this one I'm going to go up by same thing. 10, 20, 30, 40, 50, and we'll stop at 60. So our x-intercept is at 50, 0, and our y-intercept is at 0, 25. So our line then goes like that. So now it says, what are three possible, well, but let's first look at this second part. What do the intercepts mean in this situation? Well, at this intercept, it means we have 0 small plants and 25 large plants. So 25, I'll put LP for large plants. Here at this one, we have 50 small plants and no large plants. Looking at 3 other solutions though, looks like we have a point here. That could be 10 small plants and 20 large plants. Looks like we could have another point here. So that would be about 35 small plants and 10 large plants. Maybe we could have another point here. So about 45 small plants and 5 large plants. Alright, now this one says find the slope of the line that passes through the points. Now we need our equation. M equals y2 minus y1 over x2 minus x1. So we have our x and a y, and x and y. First x we have is x1, second x would be x2. First y is y1, second y is y2. So we have 8 minus a negative 2 over negative 8 minus a negative 10. Now I see 2 negatives in a row. I can make those positive. So 8 plus 2 gives us 10. Here 2 negatives in a row as well. Negative 8 plus 10 gives us 2. We can divide both of these by 2 and we get 5 over 1, or just 5. Our slope is 5. Alright, this problem says find the value of y. So what we can do is we can put this into our equation. We know our slope is 5. So if we have 5 equals, we know this is x1 and this is y1. This is x2 and this is y2. So y2, we don't know what it is, so it's going to be y minus y1, which is 9. We also know that x2 is negative 1 minus a negative 3. 2 negatives in a row, I can make a positive. So we get 5 equals y minus 9 over negative 1 plus 3, which is 2. I'm trying to get y by itself, so I need to get rid of this 2 first. Now it's being divided, so I know I can multiply it by both sides. 2 times 5 is 10, equals y minus 9. Get y by itself by adding 9 to both sides. Ten plus 9 is 19, so y equals 19. These equations say put the equation in the slope-intercept form and graph it. slope-intercept form is y equals mx plus b. So I'm going to get my y all by itself. First thing we got to do is subtract 2x. Get 3y equals negative 2x minus 6. Divide by 3. Negative 2/3 x, because 2 can't be divided by 3. Negative 6 divided by 3 gives us a negative 2. So our m in this equation then is negative 2/3, and our b is negative 2. So we're going to begin at negative 2. Our rise over run tells us to go down 2 to the right 3, down 2 to the 1, 2, 3 to the right, or opposite, up 2, 1, 2, 3 to the left. Okay, second equation, we just have to move our x over. So we get negative y equals negative x plus 6. Now this is like saying there's a negative 1y, so we divide everything by negative 1. So y equals, now a negative 1 divided by a negative 1 just gives us a positive 1x. And a positive 6 divided by negative 1 gives us a negative 6. So our m is 1. Our b is negative 6. So we begin at negative 6. 1, 2, 3, 4, 5, 6. Our m is 1, or 1 over 1. So we go up 1 over 1, up 1 over 1, up 1 over 1, and so on. If we graph this line, we'll be going straight up. Here it says write the direct variation equation. So what we got to do is we got to find our slope. So we're looking for m. We got to find our rise over our run. It's going positive. I'm going to go from this point to our 0 because we know it goes through 0. I'm going to go up 1, 2. So my rise is 2. My run is 1, 2, 3, 4. 2 over 4. And that can be simplified to 1/2. So I know that my direct variation equation, or my direct variation, means that it goes through 0. So I know that we're not going to have a y-intercept. So our equation is going to be y equals 1/2 x plus 0, or just y equals 1/2 x. Alright, so it says, given that y varies directly with x, write a direct variation equation that relates x and y. So I know that my direct variation equation is y equals mx. So what I know is that I have an x, which is negative 18, and a y that's negative 4. So instead of the y, I'm going to put negative 4 equals m, well, I don't know m, times negative 18. So m and the negative 18 are touching. That means I can divide negative 18 because we're looking for our m. So those cancel out. Two negatives are going to make a positive. I can take a 2 out of both of these, so I'll get 2 over 9 equals m. Now if I just put this m back into the equation, we get y equals 2/9 x. And that is our equation. Alright, last slide is comparing. So it says graph the function and compare the graph to the graph of f of x equals x. Now remember, f of x is just a fancy way to say y. So we're comparing it to y equals x, or our parent graph. Now our parent graph always starts at 0 and goes up 1 over 1, up 1 over 1, up 1 over 1. Same thing, straight through the middle diagonally of our graph. So we know that this is our f of x. Now it says to graph x plus 4. Well, we gotta look for our m. Our m, we have nothing in front of the x, so we can put a 1 there. So our m is 1 over 1. And then our b is 4. Our b is 1, 2, 3, 4. Up. And we're still going 1 over 1. So there's my line for our equation. And this is h of x. So now we have to compare these. So we have to compare the slopes and the y-intercepts. So if I'm comparing the m, I gotta look to see if it's the same or different. Well, they're both going up by 1, so I know that I have the same slope. Or another way to say that is parallel. Now we gotta look at the b. We gotta look if they're the same or different. Well, to me, it looks like they're not the same because they're crossing the y-axis at different places. So I know that we have different slopes. Different y-intercepts. But how are they different? Well, it looks like it goes up by 1, 2, 3, 4. So moved up 4. Alright, last problem. I need my parent graph, my parent line. That is f of x. Now my other line, g of x, my m is -2, and my b is 0. So we're going to start at 0. Now it's -2 or -2 over 1. So we're going down 2 over 1, down 2 over 1, or up 2 to the left 1, up 2 to the left 1. So if we graph this, okay, so now we got to look at both of our graphs. This one was g of x. Look at both of our graphs and look at the slope. Now to me it looks like the slopes are different. So it's different slopes. And one is going positive and one is going negative. So what that's called is a reflection. So it's a reflection if we have a positive and a negative. Now also, looks like our new equation, our g of x, is steeper than our f of x. So it's steeper or faster. Finally, we got to look at our b. So we're looking at our y-intercepts, and it looks to me like they cross at the same spot. So we have the same y-intercepts. Alright, that's it for our review. Good luck on your test tomorrow.